Okay, so I've left the bases on, and these two sort of oblong shapes would be at the same height. They just the 3D printer printed one with a little bit higher supports. But that's sort of the first thing we see. And so oops, sorry, it's off screen. Your instincts were right about that.
So it's kind of an oval sphere.
Yeah, it's kind of an oval,
smushed in.
an oval sphere. And then
as they get bigger, they merge.
As they get bigger, they merge. Now, so your instincts again sort of caught on to the two things that happen.
Yeah.
As the sphere is passing through the V, it gets a little bit bigger. Those oblong ovals get a little bit bigger, and they come together.
Yeah. Then this is the crease. You can't really see it.
Yeah, I don't. It'll be interesting if that crease shows up on camera.
It barely shows up.
Hopefully it will. Maybe if I can make it catch the light. But so there they are, kind of coming together. It almost looks like two hamburger bun tops, doesn't it?
Mm-hmm. Yeah.
Coming together. And now we have that sharp, pointy shape.
That's kind of creased.
Kind of crease.
It's got an edge, and then
I'll put the last one here in the middle so you can see it. And then it forms that same sort of idea, that sort of lens shape, almost like you see how it kind of looks like a contact lens almost.
Yeah.
And there you go. Now, just like passing through a flat plane.
Yeah.
Those, or if we go back to this three-dimensional sphere passing through a flat plane example, those circles that you see somehow add together to make the sphere. And just like a four-dimensional sphere passing through three-dimensional flat space, those spheres add together to make the four-dimensional sphere. But these shapes also add together to make the four-dimensional sphere. And why are these different shapes than when it's passing through the flat plane?
Well, because the flat plane isn't bent at all.
Yeah, it's the bending of the space that you live in that creates a different shape.
Yeah.
It's pretty cool.
Yeah.
And the question is, how would you be able to measure if your own space was bent? Because if you're living inside of it, very hard to tell. Very hard to tell.
Well, but now we can kind of go and outside our world, we can kind of look at it.
Oh yeah. If you went outside your world and passed four-dimensional spheres through it and saw what they looked like, yeah, that would be a good thing to do.
Yeah.
That's a hard experiment to do, though. Can you go outside of the world for a minute, please? So the last thing I want to do is show you on the computer. We ran out of 3D printer stuff last night. Actually, I was lucky that this finished printing. But I want to show you on the screen, instead of a crease like we have here, instead of that crease, I'm going to make it like a parabola shape. Now you know what a parabola is, right?
Yeah.
Do you? Have you ever heard that term before?
Is it like kind of an oval?
It's more like kind of like a U shape.
So it's like half an oval?
Kind of like half of an oval. That's one way to think about it.
It's like not creased, but it's not a sharp crease, but it's just kind of.
Right. There's definitely no sharp crease. That's actually really important. A bad analogy, because it's not exactly the same shape, but for purposes of this, imagine holding like a chain in one hand and the other hand, and then the sort of U shape that makes.
Yeah.
That's actually not a parabola. It's called catenary. It's a different shape, but it's sort of that. I want you to sort of generally think what it looks like. Okay? And we're going to see what a four-dimensional sphere passing through three-dimensional space bent in a parabola looks like.
Okay.
All right?
All right.